Welcome, everyone. We're actually going to get started off by giving the floor to Ian. So Ian's the executive director at Shadow Partners here and just wanted to say a few words before we get kicked off. Go ahead, Ian.
All right. Well, first of all, thank you, everyone, for joining. I'm really excited to listen into this conversation. I know that I've got my pen and pad ready to take some notes. It's going to be very informative. I won't take too long here. I just wanted to briefly introduce Shadow Partners. So Shadow Partners is really focused on accelerating innovation in the built environment through education, thought leadership, and community. So Shadow Partners offers advisory services for large corporate enterprise within the built environment to help with innovation strategy, as well as to startup companies on their journey finding product market fit. So we find that bringing thought leaders in technology and the core business of this industry together to have these types of meaningful conversations like the one that we're about to have today can really drive this digital transformation in an industry that, as we all, I think, can agree is in dire need of this innovation. So I'm really excited to always bring together these types of minds and subject matter experts to have these types of conversations. So Shadow Partners, as you all are here on the Shadow Partners Network platform, we'll host virtual roundtables and discussions on a variety of topics related to technology. And if you are interested in learning more about participating or leading one of your own roundtables, you can reach out to Nick, Heim, or myself towards the end of the call. So with that, I'll pass it over to Nick to introduce our panelists. Thank you very much.
Thank you, Ian. So we'll actually get started by introducing kind of the ACI side of this panel. So Rex and Chuck, would you mind just introducing some of the committee members that are on our panel today and letting the audience know a little bit more about the ACI committees?
Okay. We have 3 ACI members on the panel today, Keith Kesner and Chuck Larosche and Nathan Tregger. They are, let's start at the top. We have within ACI a technical committee structure that comprises about 140 committees. The top technical committee is the Technical Activities Committee. They oversee the committees not only from what they're writing, but decide whether or not they can write on a topic. They also decide whether there needs to be a new committee formed. So both Keith and Chuck are on that committee. In fact, Chuck is the chair of Technical Activities Committee.
Right.
And, pardon me?
Correct.
Correct. And in fact, they just created a new committee on machine learning, which Nathan is the secretary of. What other, let's see. You're also, Chuck and Keith were active, in fact, either current or past chairs of ACI Committee 562, which is our committee relevant to today's topic, which is repair and rehabilitation of concrete structures. Did I leave anything out? Well, I guess I did. Chuck and I are also members of one of the ACI Foundation's committees, which is the Concrete Innovation Council. So that council is responsible for reviewing new technologies, and if there's a new technology that needs to be connected to a committee or if there's a possibility of research funding, we'll approve that as well.
And so, and just to kind of build on that, we have 2 technology showcases that the Construction Innovation Council, a part of ACI Foundation, hosts every year. The next one is in Portland, Oregon. There's some interesting things going on in terms of emerging technology. We have a full plate, as well as looking at concrete strength and cylinder testing on a panel discussion. Is that correct, Rex?
Yes, we are going to introduce a little bit of controversy, which is always good on a panel discussion. The The new technologies with embedded sensors are capable of, or at least my understanding is, they're capable of evaluating the strength of concrete as it develops without the need for calibration against a specific mixture. The debate will be what, if any, means can ACI use to allow such technologies to be used for acceptance of a concrete mixture in lieu of lab-tested concrete cylinders.
And more information about the technology showcase in the upcoming agenda can be obtained by visiting the ACI Foundation's website. One of the interesting technologies that is emerging from our conversations is 3D printing and what the current code provisions are with respect to 3D printing. So that's an evolving topic that ACI is tackling.
And Chuck, you said the next convention and innovation for ACI is in Portland, right? Coming up.
The technology showcase for the Construction Innovation Council is in Portland. That's correct.
Wonderful. And on the participant side, again, if you have any more questions or comments, like Chuck said, off to ACI's website, or you can also drop a question in the chat. But thank you both for kind of introducing the ACI side of the panel here. I'd actually like to move over to the technology companies currently on the panel. So we've got Ali and John. And Ali, why don't we start with give a little more information about what you guys are doing over at AREN.
Absolutely, Nick, and thank you so much for this opportunity. So all of us in this panel and also our audience, know about the state of our infrastructure as a whole, like, it's crumbling and all that kind of stuff. And when you're looking at us as a tech company in this space, the goal that we really have is, one, reduce the risk of failure of our infrastructure system, and second is optimize the spending on these assets. So with these two goals that we're aiming to tackle, what do we do is, so we are building a software as a service civil infrastructure management platform to help both the asset owners and the engineering firms to assess and manage their heavy civil infrastructure. And by that, I mean bridges and buildings and dams and cooling towers and et cetera, et cetera. And in order to do that, you're using our unique combination of artificial intelligence, which is mostly in our case, computer vision and machine learning, and civil engineering technologies. And the whole goal is to literally create a digital health record of the asset. So, and in order to serve those two goals that we have. So since what we do is very, very visual, let me actually walk you through a few slides that I put together just to show you sort of the technology in action and give you a teaser, if you will. So if you guys can see my screen here. So we are a B2B SaaS platform. And what we do is, on one end, we are getting data from our clients, and that can be in different shapes and form. It can be images and videos coming from iPhones and DSLR cameras. Can get more sophisticated, and we can throw in drones, laser scanner, thermal data, even data coming in from subsurface of the assets. So we get all of that information, gets uploaded into our platform, and then we run our proprietary technology in order to provide a digital health record of the asset, in the sense that we provide a highly detailed 3D visualization of the asset, which you're seeing on the top right-hand side of my screen. In addition to that, we're providing a health assessment over time. So we're detecting all the damages, quantifying them, and tracking and monitoring them over time in order to be able to provide preventive maintenance plans and capital allocation plans. And this technology, when you look at it, it can be applied to different materials. For example, here we are seeing a bridge with those, cyan color showing the hot spots, which we have corrosion. And everything that we do happens in 3D. So everything is contextualized. So you don't need to look at thousands of images. You're looking at one 3D model, and now on the concrete, you're seeing the fluorescence. Or here you're seeing those pinkish colors showing all the cracks that we have in 3D. So it gives you a full idea of where you look at on the asset, what's the crack mapping, and on top of that, we're providing, as I mentioned, the quantification of everything. So you're looking at what we do and what we can do. It's, we're working with different materials, concrete, steel, asphalt, so on and so forth. And we run the whole thing on them in a sense that we take the data and we go all the way to provide all these insights on the asset. Because at the end of the day, when it comes down to, planning for repair and rehabilitation, first you need to know what you're actually dealing with and how severe the damages are and what is the state of your assets. So that's why it's very, very important to provide those kind of insights into your assets. And just showing you different cases. Now you're seeing, for example, our crack detection on asphalt. This is a 2-kilometer long runway up in Canada that we did the whole analysis, and not only we detect all those damages, but also at millimetric level, we were able to actually quantify the opening of the crack along the length of it. So again, I hope that provides at least a high level understanding of what we do as a company and what we try to achieve, which, as I mentioned, optimizes spending and reducing the risk of failure on heavy civil infrastructure.
Excellent. Thank you, Ali, again for kind of the introduction to what you guys are doing over at AREN. And now I'd like to turn the floor over to John with T2D2. John, please, if you wouldn't mind just giving us a little more information on what you guys are currently up to.
Sure. Thanks, Nick. And that was a great primer by Ali to show the power of AI and computer vision for this type of condition detection. T2D2 is also a software platform that operates in the AI computer vision space, although focusing primarily on building condition exteriors for all different types of buildings, but primarily on the building sector. I have a short video that I was going to share. That way it keeps me to time and I don't end up spending forever going through the platform, because of course I could. So let me go ahead and share this, and should come up full screen. Let me know if you can see that, and I'll walk through it here. So similarly, this is the T2D2 platform. We have built out a SaaS platform based in the cloud that allows you to visualize all sorts of inspection condition data in concrete or many other building material types. And we understand that three-dimensional photogrammetry, and I know we're not talking primarily about reality capture today, but three-dimensional photogrammetry isn't always something that is possible or desirable. So we have a lot of two-dimensional products as well, and that can be taken through any kind of condition inspection, whether it's a drone or any other type of camera, mobile device, tablet, etc. So similarly, we have a number of computer vision models that are able to detect various types of conditions in various building material types, as well as a full suite of tools that allow engineers, architects, and other inspection professionals to go ahead and perform their annotation and labeling themselves. We noticed very early on that providing and we can get into this, providing a full AI analysis of some building materials, and I apologize for the non-concrete structures that are included in this video, but there are some, that a full AI analysis sometimes gives you results that are very difficult to sift through. We think of AI as really solving a lot of that, but in reality, there are a number of challenges that using AI does bring to the forefront, and we've really invested a lot of time in providing the right number of user interface tools, which are also extremely important in the context of AI, to make sure that users are able to navigate, filter, sort, and then ultimately analyze and report on the results that the AI provides, right? And there are various different techniques that can be used to do that. You can process AI directly in our online platform, so that's something that we're super proud of to be able to do. And as I mentioned, then going ahead and analyzing the individual results based on size and length detections of the various conditions in the inspection imagery or any other kind of data format. And again, being able to see those results and then access the individual conditions from a data perspective or from a visualization perspective, right? I could see a certain place in space and I want to know all of the conditions that are present in that area. Or I could say, from the flip side, what are the conditions that I'm looking for and where exactly are they? So for us, we think a lot about what the workflow is, what the traditional workflow is, and how can tools like these be implemented in order to make that process more efficient and more effective. And I think both of those things are important to discuss because sometimes we're talking about making a process more efficient that involves a technique of gathering a lot more data. So you have to be careful that you don't open Pandora's box and all of a sudden end up having to go through more than you had intended to, and more effective because the value of more data is that you're now seeing more things. So excited to be here and happy to participate in the discussion. Thanks, Nick.
Yeah, absolutely, John. And thank you, John and Ali, both for the demos of your respective software. Because as Ali had noted earlier, we live in a very visual world in this industry. So just being able to see is very helpful. But with that and kind of the introductions to both sides of the panel here, the first question I wanted to pose is like, what is the value of the technology to the industry and asset owners, right? So architects, engineers, contractors, and then the owners of all of these structures that we're working on each and every day. And I think, Ali, you had alluded to, right,
Yeah.
life cycle maintenance and understanding costs and everything that goes into it.
Absolutely. So let me start. I mean, as you mentioned, there are different stakeholders in this industry, from asset owner all the way to contractors and engineering firms. I think let's start with the asset owner. And the reason I start with them is because they are the ones who stick with the asset for the longest period of time. Let's say it's the DOT, and they're going to have that bridge for the next 100 years. And they have to manage that bridge and do the maintenance, all that kind of stuff. So the main benefits for them using technology, and again, first, let's start by what's the status quo. We want to optimize the spending, and there's nothing such as enough money to spend. Yes, there's infrastructure bill and all of that, but there's always lack of money, especially when you're looking at it from the perspective of what's the status quo. As I mentioned, 40% of the infrastructure budget is going to waste because of lack of technology, and that's a number by companies such as McKinsey that did an analysis. So from the asset owner perspective, what you really want to do is reduce and minimize the life cycle cost, or maybe it's better to say optimize the life cycle cost of an asset. And especially, again, they have a portfolio of the assets. So it's not just one bridge or one dam, it's always a series of them. So knowing at each point in time what's the exact condition of them, and have it consistently throughout their whole portfolio, that is important, and that can help them. And on top of that, the last thing you want is to have failure on these assets. And again, they do fail. You'll look at the stats of the bridges in the States, one bridge failure every 3 days. And that can be a total collapse, and that can be a piece of concrete falls in somebody's car. So again, as an asset owner, you don't want to deal with that kind of stuff. And then you look at from the engineer perspective, yes, there's always the game of efficiency play. Now you can do more. On top of that, with technology, now you can actually go after the jobs that you couldn't do it before. So it's new revenue for you. But at the end of the day, one of the things that you want to do is to be able to be smart about when it comes down to repairs. So when you're going out and bid for a job, you want to actually know how many cracks you have to seal. Because now you can be more competitive instead of like having all these add these overheads and contingencies and this and that just guesstimating everything. I mean, now you can exactly say, okay, these are the things that I have to repair. That's my price. And even like looking at it again from the owner perspective, you're going to minimize the change orders. So all in all, using these kind of technologies, it can give visibility to the state of the asset and the portfolio of the assets. So everybody can make decisions, as we all say, data-driven, with clarity, with consistency, and with objectiveness. So I think that is one of the key things that I see in terms of how technology can help the whole industry.
Happy to add some thoughts there when it comes to value proposition. I think that's great. And one of the things that I often think about is the workflow, right? So Ali talked a little bit about value to owners, and I began my career helping engineers build multi-billion-dollar, 10-year capital plans across 570 miles of interstate. So I understand the desire to have that asset prioritization, because it's not easy, right? You're still dealing with segments that were created perhaps 100 years ago, and the same kinds of deterioration maps to understand where you want to allocate on a regional or segment basis. But it also comes down to the value that it provides to the individual engineer as a service provider. And when I think about that, I think about the workflow. Think about what the workflow is today and how to gain buy-in by industry professionals who see this as something that improves what they do on a day-to-day basis. And Nick, I know you're the moderator, but I think you might be the one to speak to this because there really is something important there about, all right, over time, data-driven decision-making, having more transparency and clarity into asset status, condition, deterioration rate, life cycle cost is super important. Those are values that will play out over time to somebody who has a long-term horizon, right? And we love owners and clients who have that long-term risk-based horizon mentality of decision making. But the reality is that's not always there, and sometimes when you're building a technology tool, you have to think about how are you improving the workflow of somebody today. And when I think about concrete, the first thing that I think about is definitely crack mapping. And I think that's the easiest workflow to sort of fall back on and see how is this improving the crack mapping process. And there are others similar to that, right? When you're going from inspection, field data capture, which now involves some amount of reality capture, all the way through to some type of construction drawing preparation, bid package preparation, and documentation. All of that, I think, is something that these technologies play an important role in, but in respecting and understanding where we have to meet our customers in order to gain that early buy-in with the early adopters.
Yeah, Keith, please go right ahead.
So let me just throw a couple points in, and I think the technology that you're showing is great. And I can remember it's getting close to 25 years ago when I first got involved with one of the ACI committees on rehabilitation. We're working on document, and one of the questions was an FAQ document. What are the sources of cost overruns on a project? And it was this lack of quantities, the uncertainty in quantities. There's always a huge issue, and these technologies are great. The next step, or the bigger question, this has got to be what Chuck's thinking right now too, is what is the damage? What does the damage mean, and how do we extract what some of the damage means? Because we all recognize concrete structures, masonry structures. You're always going to have some amount of cracking. The question is, what's the size of the crack, and what does they mean in terms of how is it affecting the reinforcement? How is it allowing water to enter the structure? So really, that's my big question as to where we can go next with this. But any tool that helps me, better access a structure so I can see certain things. I just finished up a stadium where I had to do my entire survey from basically the rear mezzanines of the stadium where I could actually access the structure. I couldn't get up close and personal with anything. So I'm guessing on quantities. I happened to got lucky and I guessed well in terms of the overall project, but we got to take luck out of the equation. So what can we do? What can we do there? But then the next question is, what is all that data? What does all that data mean in terms of how is it affecting the actual capacity of the structure? And that's really where I love to see this technology go.
Well, and to kind of build on that, Keith, I think that the subtleties that Jonathan and Ali didn't mention was distortion and deflection, which is also easy to capture through AI. And maybe, Ali, you can build upon that a bit.
Absolutely. Great point for both of you, Chuck and Keith. I will start with the latter one from Chuck. So the reason that we always emphasize on the whole 3D aspect of our technology is exactly what you mentioned. The deflection, the changing down the clearance of a bridge, the settlements that you see on a building. And because now, again, everything is in 3D, because all of those deteriorations or issues happens in 3D. So it's not a 2D phenomenon. Everything's having a 3D model that you can actually track the changes over time from deformation or changes in the geometry perspective. It's very, very important. And that's why, again, we always emphasize on the 3D aspect of things. And one of the pieces that we built into the technology is exactly that. You have the model from 2021, 2023, you do another data collection, and you do a comparison. And that comparison not only takes into account anything that happens on the surface, but also the overall geometry of the asset and how you have these settlements or deformations, changes in underclearance, and so on and so forth. So that's on the 3D aspect and why it's important. Then one of the things that Keith mentioned, which is very important, is, okay, so what? You do all these detections and this, like all this fancy stuff through AI. But so what? What do you want to do with it? The integrity of the asset and all of that. So not only is it very, very important to do this kind of detections and quantify them. Let's say you provide the width of all the cracks and the length of them, the depth of the spalling and the diameter of them, all of that. It's also important to assign a classification to them that the engineers understand. So in the case of bridges, for example, AASHTO element level is the code that we use to do inspections for the biannual. So when it comes down to the reporting that we do, we actually report in the same terminology. So with the cracks, for example, we provide the quantification and also we provide the severity classification. It goes from CS1, condition state 1, all the way to condition state 4. And we literally put every single damage in that category. And also on top of that granular information, we provide a high level summary table saying, hey, this is the amount of CS1 issues that you have. This is CS2, CS3, CS4. And the same sort of following the codes for different assets in different regions. That is what we do, because that's how the engineers talk. The engineers think about rating of an asset and the CSS and all that kind of stuff. So it is very important to build on top of what John mentioned, to sort of blend into the workflow, to augment the process in a sense that, yes, you're introducing a very, very new technology, but at the same time, you don't want to disrupt the whole workflow that everybody's used to it. So it's going to be like adding more and more information and helping people at each step of the way.
Yeah, Ali, and you've made some great points here, and I think what it comes down to as part of this discussion that we've had is emerging technologies like artificial intelligence they're another tool in the toolbox, albeit a more sophisticated one than maybe some we've seen in the past. So I'd actually like to get Keith, Chuck, and Nate, you guys' thoughts on these emerging technologies. How are they interacting with established standards such as the ones through ACI that you guys are all on various committees concerning?
So just from the machine learning aspect, so we just started a new machine learning committee that met this last spring. One of the goals of the committee is essentially to get the industry comfortable with what AI is. A lot of times, especially recently with ChatGPT and a lot of the other things that have almost made ML AI mainstream, right? It's good to have a clear understanding of what we actually mean, what is actually done, through the technologies that Ali and John have talked about. So they said words like machine visioning and those kind of things. A lot of this, what we're trying to do is to boil a lot of it down to things that we're familiar doing, right? Whether it's control charts at a ready mix plant or, and using AI techniques to, like John said, get into that workflow and automate some tedious things, right? It doesn't have to be the most complex neural net kind of play chess kind of thing. It's more of just, hey, there are things that need to be repeated in a very efficient way. And especially with media, that's hard for us usually to quantify. So images, right? How do you take an image and kind of classify it in a certain way? Well, there are a lot of established techniques that have been used in other industries for decades that can be brought in and used here. So, I'm just wondering from Ali and John, at some point, trying to understand how easy it has it been talking with your customers, getting them familiar with your products, and because the other half of this is, I'm sure, because I've dealt with this in another aspect for our company, but the visibility like you talked about, some people have never had this visibility before.
Mm-hmm.
Have this many, records and details can be overwhelming sometimes. So it would be good for you at some point just to talk through how your software can help alleviate some of those things and help the customer with those problems.
Yeah,
absolutely. Go ahead, John.
I think that, just like we were saying before, it's all about meeting everybody where they are in terms of their process, and to that point, a lot of it is not getting people too overwhelmed. So I think that whatever way that you're going to build a technology product, it has to be using a process that incorporates as much user feedback as possible. So one great example is, just take generally the fact that historically in the inspection space, a lot of people, and this has to do with structural engineering, anything that you're doing. A lot of engineers historically think in 2 dimensions because everybody's always looked at 2-dimensional plan sets. So simply being able to buy into the idea of thinking 3-dimensionally it makes so much sense, but it requires a little bit of this leap in terms of process. And I think that what you want to be able to do is make that easy, right? So you have to understand people's mindset, and then you have to make sure that people aren't overwhelmed when they look at something, and tools that are frankly outside of the AI component of a lot of these tools is what does that, right? It has to do with the visualization, it has to do with the filtering and the labeling, so that you're able to take it and classify it into those recognizable structures. And I think that a lot of the technology products out there do try, once they are able to surmount some of the AI hurdles, then they quickly realize that they have to tackle some of the user interface components to make it to get it to a level where it's accepting. Because one other thing that I'll mention is, and this has to do with AI in general and the AEC space, is I think that, and I'm saying this not as a non-engineer, I do think that engineers are some of the most shall we say, discerning customers that are out there in the marketplace. They are very. You have to do a lot of convincing to get them on board in some cases, especially when you're not dealing with early adopters. And what that means is you find yourself having to do a little bit of education around the capabilities and limitations of AI, and we can have a conversation about that as well. But I think it's important to understand in order to communicate the fact that in many cases this is built as a tool and not as to provide all of the answers that somebody may be looking for.
And
I think. Oh, go ahead, Ali. Go ahead.
Oh, sorry. And on top of what John mentioned, so you had 2 questions, Nathan. One, it was like how you incorporate within the workflow and helping them and sort of communicate what you do and make it usable and friendly to use. And the other piece was how you get the buy-in from the engineers to use AI and things that they're not used to. So I'll try to answer both of them with my here. So part of that is whenever we're talking to our clients, and that's a result of my personal background, is we're saying, hey, we're not an AI shop that does apply AI to everything. Like, we are finding cracks, we are doing solar panels, we are also finding trees on the way of railway system. Like, There are shops doing that. We are not one of them. We are a civil infrastructure tech company. We are not an AI company. And it happened to be like, I personally, I'm a civil engineer. So I did all the way PhD structural engineering. I hang from bridges to count cracks. I did all of that kind of stuff. So there's also this personal background that helps when we communicate. Talking about the workflow, we have to all realize that we don't give the engineers the best tools to get to do their job properly and the best possible way. We still ask them, as I did it back in the day in the previous life, to again, like, do the rope axis and start to count things. And while they're on the rope, like, put the crack gauge and measure something and then take a photo and remember where they took that photo and put it in a report. Like, we're in 21st century. Let's do things better. So that's one thing. Like, let's accept that we don't give the engineers the best tools. And the other piece regarding the AI, that education that John mentioned is very important. And also it's very important as you communicate with the clients and the engineers, not to keep saying, oh, AI is a black box or anything of that nature. No, AI is not a black box. Like, it's a human made. How can it be a black box? So just sometimes take them behind the curtain and show them what it does, and give them transparency and like, okay, these are the limitations, and this is, these are the strengths, and this is how we fix this, and this is like, give them that clarity, and even like be open to the test, like test in the sense that, oh, you want to validate something? Be my guest. We welcome that. Go ahead with a crack gauge and start doing the measurements. Take a microscope out there and start doing the measurements. Like, giving that, confidence to them that, hey, we know what we are doing. We are understanding your problems. We have dealt with those problems, and now we're building a solution tailored for you. It really, really helps when it comes down to adaptation, and when it comes down to sort of, again, augment the process and be part of the pipeline of how they go about doing their job.
Yeah, and Nick, just to bring that all back to your initial question, just as they just outlined here, getting things pushed through codes and standards, we're kind of trying two parallel approaches, where one is trying to reduce AI to what it really is, whether it's statistics or it's automating processes, right? Something that the industry can be more familiar with. So then we can make a decision, hey, is this really a change needed for a code, or is this just another tool that helps, that's in that workflow? And then the other part too is a bit of an education to help people to understand how AI works in different sense. I'm saying AI like everything is the same, but of course very different methodologies for different applications. So it's educating people to help them to understand where it's useful, where it's not, and how to test it, like Ali was talking about, how to pressure test it and make sure that, hey, these are the limitations and how do we stay within, and all those are going to be parts of guidelines that ACI regularly puts out. And then we'll just have to figure out how that gets folded into code. But I think, just along those lines, Chuck had mentioned 3D printing. That's something that's very new recently. And people are making houses right now, whether, how are those getting certified and all that kind of stuff. It's definitely something on the minds of ACI.
And Keith, I see your hand raised. Please go right ahead.
So there's a couple things I'd like to bring in, and one of the things that I find to be critical, and I'm sure Chuck has the same thought, it's, you're going to show me a new technology, but I'm going to very much ask you to verify it, because you're asking me as a design professional to use your technology to help you survey the building. And I fully support, having people, whether it's drones or other types of image processing, to help survey these buildings. But you really need to convince me that you're finding all the damage and verifying sufficient results, because that's really where it comes down to. If you're doing something like a facade survey where critical things are, our first goal is obviously life safety. And that's really, that verification that you're identifying the damage is really critical. But you also, let's talk about, I'm going to go back to facade surveys for a second. So traditional method, maybe a swing stage. Now we have more and more people are doing rope access, but you with a drone or some other type of photogrammetric surveys, you can see a lot more of it. But are you seeing enough of it? Because that's always the question. If I do one swing state drop on a building, is that representative? If I then do more rope surveys, is that more representative or less representative because I'm limited by my rope? Now you're looking at a whole structure in theory, but are you getting enough granularity in your survey, and are you able to verify your results? So it's, we're always having these same questions, and to get things into the widespread acceptance into codes and standards, that's really a tricky part, and that verification, I think, is the critical step. So I'll leave it at that.
No, and I'm going to let Rex expand on this a little bit, but one of the challenges, and I'm sure Ali, you and John can relate to, is getting things to industry, right? Getting things codified in a way that it is now the standard of care. And I think, Nick, that was kind of your question way back when, if I didn't lose focus, which was, okay, we have this great idea. How do we get it? How do we move it forward into industry? And ACI has been tackling this, and one of the ways that they have expedited some of these solutions is through, instead of the standard technical committee, whether it's 318 or 562, we have ITGs. And ITGs were created to advance technology through the Institute and get it out to industry at large, get it out to the code officials, get it out to the municipalities and the authorities having jurisdiction. And Rex, I'm going to ask you to kind of expand on that a little bit. What is an ITG? How does it work? And some of the success stories. And
an ITG is an innovation task group, and it rather than being a purely volunteer group, it's a task group that has funding to support travel and meetings and other expenses. They normally act rapidly on a technology. I think a recent one was on,
high strength steel.
High strength steel, because we're moving from, we were 40 KSI, 40,000 PSI steel back in the 40s now, and then it was 60,000 when I was a kid, and now 100,000 PSI or 100 KSI steel is common. So we had an innovation task group look at how that yield condition, because a high strength steel doesn't have a nice elastic, perfectly plastic behavior. So we had to have a look and see how that would affect the ductility of structures, particularly those that are located in seismic zones.
And it's unintended consequences, right? Rex, I mean, sometimes we had this demand. We wanted to reduce congestion in columns.
Right.
And we certainly pursued that with endeavor, and we were able to do that with high strength steel. So the first thing, when we reduced the number of bars, my architectural colleagues reduced the size of the columns. But it is a challenge to get these things codified, and Rex and I are working vigorously on 3D printing. 3D printing's an exploding industry, and we have a lot of the code officials presently are relying on what's called an alternative method, which is allowed in the International Building Code. The challenge with the alternative method is it's also proprietary. So if you are a 3D printing company and your alternate method has been endorsed by the international building community, well, for the home builder, I've got to use that system, not just 3D printing in general. And so that's a challenge. That's a challenge for ACI. It's a challenge for industry. It's a challenge for the code officials to advance that forward in a more global manner, to which 3D printing is then widely accepted nationally. What'd I leave out, Rex?
I think that covered it pretty well. I've got a few questions going back to the ground truthing for the data. When a client asks you to ground truth or to go in and measure, do you reincorporate those findings into your training set? I guess, are you continually updating your models?
So we are continuing updating the models. That's something that we do. So that we have incorporated what we call an active learning loop. So whenever we are doing a new project, and so our models keep seeing new concrete surfaces, and now we're in the millions of photos that we train. So that is already in place. Regarding the ground truthing and the validation, so it happens in 2 steps. And that's what we also tell our clients. So first is we walk them through the whole how we build this technology. We tell them that, hey, we spent like more than 10 years just building this technology from ground up. As we all know, for example, training data set for building damages or bridge damages, anything of that nature, that doesn't exist. We don't have an open source. It's not like autonomous vehicles. So even that data doesn't exist. So you have to start somewhere. So first we walk them through that. Hey, you spent 10 years, like several patents and all that kind of stuff. And then when it comes down to, okay, now you give me a report, how can I make sure this is legit? First, again, we tell them, in addition to all those details that went into building this technology, they have a very rigorous QA/QC system in place that verify every single issue that we flag and we report. And sometimes, especially when we are dealing with very sensitive assets, and for the comfort of the client to actually put in a human in the loop to do a QA/QC on top of the results that we're providing, just to make everything bulletproof. And whenever the client is, sometimes they tell us, and sometimes it's a fully blind test regarding the going out and them checking and what we did and do the validation. We always welcome that. We had clients, go ahead and do, like, as I said, crack gauge and do the measurements. And we also had people that literally took a microscope out and like literally measured the crack over the length, and they did the validation that way. And whenever we went through that process, we validated our clients. So we always welcome that, because we know that's part of the adaptation. That's part of, you're providing something that the people make decisions on it, and these are high stake decisions. So you cannot mess around. Everything should be bulletproof. And that's how you should even communicate about what you do as a company.
We've talked a lot about photos. I know IR produces visual images, but for building cladding, for example, do you use infrared data?
We do use infrared data as well for buildings, for concrete deck of a bridge, to finding the lamination and voids and stuff like that. Even acoustic sensors, we also blend in that information in. So the goal for us is to be as source agnostic as possible. Get all the data from the asset, fuse all of that data, give the holistic view of what's actually happening in the asset.
Okay, my last question then. Looking forward, if I've got a 3-dimensional view of a structure, I can extend that to a transportation system, and then I can extend that to a transportation system that extends from state to state, and different states use different details. Looking forward, are these data going to be used to train future engineers so that they won't incorporate the same bad details year after year in their future assets?
The short answer is yes. The short answer is absolutely yes. Because one of the things that it's important to realize that having granular data from your asset is going to give you certain visibility that you never had it before. For example, let's go with the bridges, transportation systems. And, there are different structural systems that you use to design bridges and then build them. Having the granular information over time can tell you, okay, what were the flaws of each of those designs? Like, which design wound up having the worst amount of issues versus the other one. So you can start to look into, at the macro level, understand how your assets behave, how they're holding up, what concrete, hold up better, what design was better. And all of that can go into education of new engineers and like sort of start to do this lesson learn, not to do that, do things differently. That's how we see in terms of byproducts of all of the things that we do.
So how could an organization like ACI tap into that data for its educational materials?
That's a good question. Right. I mean, these data in sense of, I have to think about it. Right now, I don't have a good answer. Like, how is that possible in terms of working with ACI, for example, to help with the education? But again, part of the information is going to be available to the public in terms of like what is the state of the asset and like stuff like that. Even FHWA has a portal providing information regarding the bridges, but it's just very high level, and ours is going to be more granular. But something to think about. Rex.
There are a few things that I would say in response to what Rex had mentioned. And it's interesting seeing a few different technologies that accomplish similar objectives, right? Today, you can go ahead and sign up for T2D2 and begin running pictures or models through AI immediately. And because it's more of a self-serve platform, we have fewer human-in-the-loop solutions that we do offer those as well, but in those cases, it's important to really understand that not every single project would necessarily be used for retraining, right? Where we curate our retraining pipeline to be specifically for certain projects that we've been able to validate. So understanding exactly what goes into the retraining of models is definitely important. And I also wanted to point out, when it comes to measurement and ground truthing, actually, it's somewhat funny mentioning people going out on site and measuring with microscopes and meters, because someone told me a story recently about an engineer who many years ago did not believe in the Lotus notes or the Excel tabulation of the sum of a column of data. And they insisted on calculating that data by hand every single time until they believed that the actual sum that the computer was calculating was right every time. Whether it's teachers protesting the use of the calculator, I think that we see this time and time again, and this is the new wave of that in terms of trust and verification. And on top of that, it's also important to know that there are certain industry standard metrics in order to measure the quality of certain artificial intelligence products. So there are measures like precision and recall and others. And we actually have seen globally some standards, and I'm talking from experience in the building exterior inspection space, we have seen globally, yet to be adopted anywhere that I've seen so far in the US, but in other areas, they have adopted certain standards that specifically call out certain quality measures to make sure that anyone who wants to either self-certify or be certified as having met certain qualifications, that they can attest that their product has met those measurements of model quality. And that's probably a little bit of prying underneath the hood, and some technologies will openly talk about the quality because they want to defend their effectiveness, and others may not be so forthcoming to share certain data, especially because those types of questions, when it comes to vetting those technologies, there are very few customers in the market who are even asking those questions, right? So if you're informed enough to begin asking those types of questions to AI companies, you're way ahead of the pack in terms of discussing the complexity behind in some cases, the simplicity behind some of these features.
And Keith, I think I saw your hand go up.
I'm just thinking about the next step for this. And you when you talked about bridges, LE, and different generations, and Rex talked about different states, and we talk about the other thing that I tend to think is similar is, let's just take an example, precast parking garages.
Yep.
We can look at precast parking garages made in similar double T's, 1980, 1990, 2000. track it through. Now, can we use the AI data from some of those to start to do service life predictions for some of the details that were commonly used in certain time periods, and how some of that predicts and how some of that changes over time? Because really, that's kind of how we can start really improving future designs, is to start looking back at, what the track record is of different types of structures, different environments, and then have a predictive loop, whether it's, some sort of a Life 365 where we start to incorporate some carbonation and chloride data or something else to try and create that predictive loop so that we can actually start, concrete repair, the improvement of the concrete repair industry. We're sort of putting ourselves out of business, but as I think Nick mentioned, we're not going to do it. So that's kind of another direction for this, and I'd be curious to see if any thoughts on that.
What's interesting about that comment, Keith, is, as you know, we went from 10-foot tees to 12-foot tees, but because the precasters
15-foot tees,
because they had heavily invested in their beds, they didn't change their stem to stem spacing, did they? And so we can be smart about AI, but sometimes other factors, economic factors, drive those decisions.
That is correct.
That is correct. And back to the point that Keith was mentioning in terms of prediction, there's an important piece in between that we have incorporated and we are providing that it's commercially available, and that's a change in time analysis. So in order to predict the future, you need to understand how it's changing over time. And going back to what Nathan was talking about in terms of just, let's not just use AI, or it can be a simple regression, like it's stats, like based on previous data, see what's happening next. But that is a very important piece, like the change in time analysis and understanding how your asset is degrading over time, by what factor, by what percentage, in what areas. Like after having those kind of granular information, of course, and 100% agree with you, the natural next step is prediction. Now you start to build service life curves and say, okay, this is how it's degrading. If you don't do anything, 2050, you have to say goodbye to your parking garage, to your dam, to whatever asset that you're managing. Yes. That is the natural next step.
And I would add to that so there's looking at it over time, right? And some of that is looking at the deformation of the structure in 3 dimensions over time. Some of that is trying to find that crack and associating it from point A in time to point B in time, being able to actually do essentially what would be facial recognition for crack detection, and then seeing the change over time of that exact crack, right? However, in addition to that, and a little bit also in the answer to Keith's question about, can we tell what are these cracks telling us, right? What is the underlying cause, and where are there more concerning cracks versus some that may be more superficial? Well, both in the answer to that question and the question of where do we go in the future here, the answer really lies in the systemic AI analysis, right? Where instead of really looking at the skin whether it's 2-dimensional skin, 3-dimensional skin, really understanding more of the segmentation behind the structure and looking at it as a complete whole. And there's some really exciting technologies out there right now in terms of simulation modeling and physics modeling, where we can apply AI based on all of the data that's ingested, whether it's from drones or other sensors, to better understand the answer to, of all the cracks, which ones are today of more concern based on a full systemic AI analysis, and then where should we be concerned when it comes to predicting service life and some of the areas that may be more susceptible to rapid deterioration. So that's really exciting.
And on top of that, the way that we're thinking about it is, as a company that uses AI to serve this market, we are not, looking at the future, we are not interested in incremental efficiency gain. Like, hey, we're going to help you to do crack mapping, for example, 10% faster, 20% faster. Like that's all good, but that's not going to fundamentally change anything. We have to look into how we can change the landscape, and that landscape, how we can do that, like predictive analysis, change in time analysis, prediction, understanding, okay, how materials actually behaved over time, which design was better than the other ones, like which, I don't know, manufacturer of epoxy to inject into crack wind up being the better one versus the other. Like all of, like, we want to get information about all of that, because all of that is going to help us with the two goals that I mentioned earlier in the call: optimizing the spend and reducing the risk of failure. In order to do those two things, it's not going to be like, oh, I'm going to help you find your Spalding's 10% faster, or 20, or even 50% faster. Like, sure, there's this next big thing that we should tackle, and that's what we are, quite frankly, interested in.
And we've had some excellent discussion here, and I know on the agenda there was a Q&A section, which thank you to Rex for spurring some very interesting discussion points. We're about 3 minutes over on time now, so what I will say is, if you've left a comment in the chat with a question, I will actually follow up with you on that. If you think of any other points of discussion or questions for those in the audience, please message me on LinkedIn, or I will drop my email in the chat and I can help follow up with the panelists on those. But before we conclude from the panelists, thank you again so much for joining us. Any closing thoughts or comments before we end?
This is just the beginning. That's all I have to say. I think this is early stages of what you're about to see as a real revolution in AI and its use in the AEC space. And it's definitely going to, in the next few years, be a matter of who is using this in the industry versus who is not. That's all I'll end with.
And on my side of things, I would say, in order to push the industry moving forward, we need to have visionary stakeholders at different sides, from visionary associations like ACI, ACE, all those kind of, groups, to the asset owners, to the engineering firms, contractors, general contractors, startup founders. Like, we need visionary people in order to push industry forward. And there's a lot of push and pull that's going to happen. But, the key thing is when you're dealing with the status quo and how you want to change it. I love this quote from Ford saying that if I had asked people like what they wanted, they would have said faster horses. Like, that's not the game that we have to play. It's like building the car, giving that, that just literally thinking about how all of us can move this industry moving forward, and not to be one of the least digitized industry on planet Earth. It's just bad for all of us. I mean, I'm saying as a civil engineer.
Nate, Keith, Chuck, any closing thoughts?
If anyone's interested in machine learning, ACI 135, please come and join. You'll meet people like this. There are some industry members on there, a lot of good students if you're looking for students as well. But it's definitely a very busy committee.
And I just happened to drop the technology showcase event and location in the chat. So please feel free to join us in Portland.
And as a closing thought, everybody always tells me ACI is such a slowly moving thing and technology is always so slowly changing. But if you look at what's happened just, in the last 5 to 10 years with the new ACI committees, the new machine learning, all sorts of new stuff, the industry's changed a ton, and it's never going to be as fast as people think it should be, but it is changing, and just be part of the process. So, and thanks to the participants, this is a good discussion. Thank you.
Rex, any closing comments on your end?
No, well, just thank you to everyone. It's been great. I've learned a lot, and I'm looking forward to seeing all of these things in use every day, everywhere.
Okay, so again, thank you to the audience for joining us today. Thank you to all the participants, again, for donating some of your time to these discussions. And there are definitely more to come from the Shadow Partners networking community. So everyone, please enjoy the rest of your week, and we will see you next time.